Hello, welcome back to Sushi LiveNoding. In this episode, we're going to be revisiting the creations of this Zenga blocks inside Blender. So this is the classic one, and that's actually more interesting, but that's going to be for the next. Anyway, so this is what we have at the moment. This was actually generated on the fly and seems slightly complicated here, but it's actually rather quite simple and quite interesting, and it's something that you should try yourself at some point to create from nothing. So I actually started from a simple box, and with the box I have this transform mesh that's simply scaling the box, so it's giving me the shapes that I want. So you can actually reshape it into anything, and if I play back, it will actually work. So it has some rigid body dynamic that I set up earlier, right? So let's give it this. Let's make this shape again once again. So it's 1/3 in the X, and the Z is 0.4. I can make it thinner, or back to the thickness that you want, but let's just round it. So okay, this is transform mesh, and this is our basic elements of the block. You can see we have 52 of this block. This is actually the floor. So 52, and we just say it's matrix, which is the transforms that's actually being generated on the fly. So this part could be slightly intimidating, but they're not. How did I get into this point? So basically my idea is I started with a, let me draw the plan. I created a line, and I make duplicate of the line, and I know that this is gonna be, these points can be the positions of our Zenga block. So that's my logic, and then I duplicate it up, and every time I duplicate it, I also rotate it and stack it. Okay, so but rotating the line doesn't mean it rotates the block, so I need to rotate the block as well. So we get these numbers, and those are actually the parameters. Currently it's a bit all over the place, but it's gonna make sense real soon. So I actually started from a line that I told you. This line says size of 2. I can make it size of 3 or 1, or actually smaller, so it's becoming like a little bit like a hashtag from the top. The number of vertices is actually from this guy, so we can have Zenga block that looks like this. This is the number of the block. If I change the number, something will change with the rigid body, right? If I just change it 12, it will still work. If I make it 36, you're gonna see, okay, the rest of the Zenga blocks will not work because the rigid body is being reset. So with the rigid body stuff, that's something that can be fixed and made procedural. So basically, this guy doesn't have rigid body, but the rest of them got it. So you just need to link the rigid body, if I'm not wrong. Object rigid body, not constraint, copy from active. So now they should have rigid body. So that's that. And if you want to make it more procedural, you can do that as well, simply by putting the objects into the rigid body group or something. Yeah, you just need to reapply on the fly. That's possible. I remember it's possible using animation nodes, but we are using SVerchok at the moment, so don't worry about it. So two lines. One is controlling the number of blocks, and the other one is for the stacking. This is the step between stack. This is the matrix that's kind of multiplied. So there's a 90-degree rotations that's being applied to this line, and I'm using matrix apply to join them together. And for the extra rotations, I actually have this. So this one will actually randomize the block slightly, so it's rotating it slightly, so it's more natural. So Zenga block can never be perfect unless you arrange it super perfectly. I have this number. Oh yeah, 0 and 90. This one is this is the one that's actually doing the rotations as well, and it's generating the number that's like 0, 0, 90, 90, and so on. So it's like a kind of number that grows. So the first block have 0 rotations. Second stack of the block will have 90-degree rotations with a slight variations there. That's actually thanks to this number range and list repeater. So this one is important, so it's gonna repeat. If I zero this out, it's probably clearer. So second stack have 90-degree rotations, the third stack 180 rotations. So it's interesting. It's not like, I mean, it could be just some kind of very basic algorithm. I think the whole thing is it has certain rules, or maybe there's descriptions or rules, and then you apply it to the original elements blocks. So the blocks above can be anything. If I change this box into a cylinder, it's gonna look very different. Maybe I should try that, because that's really the power of this procedurality. So box, I can start with a cylinder. Cylinder needs to be, I think the size or something will be different. If I just plug this box into that guy, and resize it, so suddenly we have a stack of cylinder. Or maybe like a coins, and it will still work as a rigid body, but it's a rigid body block, so this might be slightly wrong. But we can actually rotate the cylinder and scale it. So let's rewire this from Z, rewire to maybe X or Y, and make the radius slightly smaller and increase the height. So we have a different stack, maybe like a kind of like a bamboo or like a pocky, but you see the rigid body is actually adapting to this object as well. So it's pretty cool. It's gonna try to stack itself. Okay, it's overlapping, but it's possible. Anyway, it's possible to properly arrange this, because we can control almost pretty much everything. And we can randomize slightly. Let's play back. So it's quite powerful. It's really basics, but something that you want to try and play around yourself. So each of every object is not combined. It's a single. Each one of them is a single object, and it's simply just work because yeah, underneath it's just like if you think about it, all the nodes is just like descriptions. They call it in term of coding. You can just delete everything once you've done with it, and just playback rigid body. It's actually a lot faster because Blender doesn't need to calculate SVerchok anymore, right? And you can play the Zenga. So let's try and just animate the floor, for example. Oops. Let me undo that. Select the floor, turn on animated, and then you can play around. Great. So there you go. That's a quick look at how we can make the classic Zenga block stack using Blender and SVerchok nodes. Thanks again for tuning in, and I'll see you next time. Bye.